I'm gonna start the recording and yeah. Hello everyone, welcome to the fourth introductory Unity workshop. We will be getting into basic FPS mechanics, and also I will be showing you how to use particle systems. Maybe I can just go by myself. Maybe it's better. So yeah, I tried to make this workshop a bit straightforward. Like these are basically the four general topics that we will be covering. So we will be basically, since this one is going to be a first-person shooter game, we will work on the camera rotation. We will also move our character on 3D, and I will show you a simple shooting mechanic, and finally we will have particle systems to create explosion or like impact effect after we shoot our gun, pretty much. And also, like as you may remember from the previous workshop, from the bullet hell one, the shooting mechanic that we used were basically projectile based. So we were basically creating those little bullets that were sort of like a part of the physics simulation, and they could basically impact with our player and like react based on how we implemented our code. But in this workshop, we will be using a raycast based shooting mechanic. So basically, whenever like we will have a gun, and whenever you like direct it to somewhere, and like whenever you press the mouse button, it will create a ray basically, and if the ray collides with any of the objects, it will like create an impact effect over here, or like maybe like we can also access this game object as well. So maybe like we can decrease its health, or like maybe we can do some other functionality as well. So yeah, that's basically the general plan I had for this workshop. We can slowly get to the editor. So is yours working now? Like, is it ready?
Yeah, it's right.
All right. So yeah, if we open up, I guess I can just close that up. So yeah, when you create a 3D project, the thing you will see is basically like this. So you can basically go around by just doing right click. Like if you hold right click and like move your mouse, you can basically look around. And also like you can use your scroll button to zoom it or like zoom in or out. And also like I usually prefer using it. I usually prefer using arrow keys. Like if you use the arrow keys, you're gonna see that it's zooming and like moving at the same time again. Like, and if you hold shift, it's obviously moving faster. So yeah, we can get to creating game objects. So what I want to do first is that I want to create a 3D object that will be a cube. And yeah, like after we create it, you're gonna see some stuff are sort of like different from what we had when our game was in 2D. So like we don't have sprite renders anymore. Instead, we will have mesh renders and mesh filters. So I won't be getting into too much details with them, but basically mesh filters are sort of like providing us with the shape of the object that we just created. You can, change the mesh filter into a capsule, a cylinder, a cube, but I'm just going to stick with a cube. And mesh render is going to be used for, setting up the lighting, probes, additional settings. Like, to be honest with you, I don't really know much about the things. Instead, we will be mostly focusing on materials, but I will get to that shortly. So I want this cube to be our main surface for our game. So you can just stretch it out to something like this. That will be basically the surface that our player is going to walk on. And also, like I mentioned earlier, I tried to make this workshop as straightforward as possible. So I won't be using physics. So, but I will be using the surface just to, visualize things a bit better. So like if you want, you can just rename this cube into something like surface. They will be here for like visualization. And also like if you want, you can create cubes as well and like maybe stretch them on the y-axis to, I don't know. You can just move it around to maybe like create walls or something. Like it's really up to you. But I'm just gonna stay with some like little basic poles. You can just copy this cube and paste it to the game scene and like move it around. It's mostly the things we have done like throughout the semester. Yeah, just like that. So yeah, just play around with it, get comfortable with it. And like, do you have any questions so far? Like, we just created a surface. We're just stretching it around. We're just creating our map, sort of thing. It's pretty straightforward. And also, I mentioned materials before. So, like, if you remember when we were like working with Unity 2D, we had sprite renders and like we could change the colors of the sprites easily. Instead, we are going to use materials here. So, however, the default material is basically locked. You cannot edit it. So instead, what we're going to do is we're just going to create our own materials and we're going to change that materials colors and other like textures and stuff. And we're basically going to work on it. So what I want you to do is just create a new folder and name it materials. Just like that. Basically, that's the folder that we're going to place our materials. Yeah. And you can just right click to the like materials folder. You can either like go inside it or like you can just click it, right click and create a material. I'm just going to keep it right over here. When you right click to it, like you'll get into this create tab and you can basically find the material right over here. If everyone is fine with it, I'm just going to click it. So yeah, we just created a new material and we can just name it whatever we want. I'm just going to call it like surface material. I'm just going to use this material to, give the color of our, surface. And basically you can just change the color of the material. You can also play around with the rendering mode. To be honest with you, I don't really know much about like how they work and stuff. But anyway, since we created a new surface material or like any material whatsoever, so like you can just drag and drop it right to the mesh renderer of our surface, just like this. And now, and also you can just click to the like little dot right next to the text and like find other textures as well. Like most of them are provided to you. I don't think we can make changes to the ones that are provided to us. I guess Unity is using them for like other stuff. But yeah, what we have done so far is basically like we attached our surface material to our surface's mesh render. And we can just like if you make changes to the colors and stuff, or like if you I don't know, like make changes to the smoothness and stuff, you're gonna see some differences. Like just play around with it, get comfortable with it. This one is basically a little detail, and you can obviously do the same thing for the polls that we have created as well. Um, yeah, and you can also create new materials just like that. And yeah, um, any questions so far? Like if not, I will go forward. All right. So now, I just want to create our player character. So yeah, if you right click 3D object, I want you to create a capsule, a basic capsule, just like this. And most probably it will be created like outside or now. I don't know. You can just change the y-axis to 0 to easily find it. And like since we are working with, I don't know, like 3D, it might be harder to find our players and stuff. Like if you lost, like if you're looking for a specific game object, you can just double click to the game object so that like the Unity editor will zoom to it. So yeah, just set our, let's just set our player character and also like name it to player. um yeah, be sure to keep it upwards of the surface so that it will be easier for us to find. And if you want, you can change its color as well by creating a new material and applying to it. And yeah, just to keep things a lot more simpler for this workshop, we're just gonna work on just single one, like just one script. Um, yeah. Oh, and also maybe it would be a good idea to show this one as well. So yeah. Oh, main camera. Where's our camera? Right over here. So yeah, if you move the camera, obviously, like I assume you all know how camera works. It will be basically like when we were working with 2D as well, the camera was a thing. And like whenever you move the camera, whenever you rotate it and stuff, it will be shown in the game section, right? But since we are going to make a first person shooter game, the camera will be actually our player, just like this. I mean, not like this, but yeah. So what I want you to do is I want you to um, drag this main camera and like place it inside the player. Now, this camera will be bound to the player. So what I want you to do is like if you're, yeah, like have you all done this? The main camera should be the child of the player. Yeah, if you have done it, let's just click to the main camera and change the position to 0. We're just gonna reset the position of it. Like the positions to 0. And yeah. And you're gonna see that our camera is located inside our player. And like maybe if we like move it a bit upwards, like maybe I should use a better color. It's too tiring. Yeah, just like this. Now our camera is basically a part of our player. And also, like if you click to the player and like if you move it around, you're gonna see that the camera moves around with it as well. So whenever we move or like whenever we rotate our player, the camera will be also rotated. And you can also just play around with it and see that like you can just dock the game screen to the right next to scene, and like whenever you move it you can see the differences and stuff. Yeah, any questions so far? So we just attached the main camera to our player, we reset the position of our main camera and slightly changed the orientation of the camera so that like it's in the face of our character. Like maybe I can just decrease it a little. I don't know. And what I want to do, what like I want to also create a gun game object. So that's basically that's like I assume you all played first person shooters. You usually like see your gun when you're playing the game. So I kind of want to have a similar thing happening in our game. So like right click to the player and just create a 3D object and create a cube. I'm just going to keep it here for a while. I assume you all are ready. And yeah, and definitely change the orientation, change the scaling of the gun so that it is a bit better. Maybe just change the position as well so that like it can be seen on your game as well. So yeah, obviously there are like tons of better ways to, create a gun game object and like attach it to your player. This one is just for visualization. You can also like play around with the orientation of the camera so that you feel more comfortable with the gun game object. Just like this, just rotate it around, and like you can also keep the game screen open so that like you will have a reference. And like this one is just for visualization. Like for this specific workshop, you don't really have to create a gun game object because like we're gonna be shooting inside our character sort of. But yeah, like it will be better if you just create a gun game object like this. So any questions so far? Are you able to done it? Like all of you? Are you okay? Yeah, perfect. And then we can basically get to the scripting part, pretty much. Like I said, I will be just having just one script. What I would recommend for your like later project is that like try to modularize things as much as possible. Like maybe if you remember from the previous um, workshop, we had this game manager and stuff that keeps everything in its own places and stuff. But just for simplicity, I'm just gonna create a player script. Just click to the player game object and get to the add component part. Or like there are multiple ways to create scripts, as you may all remember. You can also just create a new folder and call it scripts. Um, this one is not required, but it's a good practice to keep everything in its own folder. And just you can also just create a C# script right over here and call it player, just like that. And don't forget to, oh, it's compiling. Yeah. And after you created this player script, don't forget to attach it to our player, just like this. Yeah, simple as that. It's usually the thing that we have done. We just created a player class or script and attached to our player. And now we will get to the coding part. I'm just gonna make it a lot bigger so it's easier to see. So what I want to do is I would like to start by like providing the functions that we're going to use throughout this workshop. So first, we're going to have a private void handle mouse rotation. You could also name it something like player rotation. It's really up to you. And the other one is private void. Can you see it, by the way? Maybe like I can just make it a lot bigger. Just basically interrupt me if you're like having hard time seeing it. And the other function will be called handle player movement. And the names are, I think, pretty self-explanatory. And finally, we will have private void handle shooting. Yeah, just like that. And like I mentioned earlier, I just want to start with mouse rotation. But first of all, yeah, maybe we can just place them inside the update function to show that like three of them will be called within like each frame. Yeah, just like this. Like all of them are empty. They like these three functions will be what we are going to do for this workshop. Pretty simple. So yeah, am I missing anything? I guess not. So yeah, let's start with mouse rotation. First of all, I would like to create a global variable. I'm just going to explain it afterwards. A vector tree called mouse movement. So this one will basically keep track of the mouse movements we have done so far throughout our game, and we will do our rotations based on this simple vector. And if we get to this part, I'm just gonna close them up to make them less distracting. So yeah, we're gonna make changes to the mouse movement based on our input. Maybe it would be a better idea if I explain it after everything is all set up. Input get axis and mouse X. Be sure to don't have any typo over here because like this sort of like string is fixed. The compiler won't warn you if you have any typo there. And yeah, maybe we can just keep it like this. And same goes for mouse movement.y. Input get axis mouse y. So if you attended the first workshop, this one is basically giving you a value between 1 and -1. And this like mouse X, mouse Y, and there's also like other versions of it which we are going to use in this workshop as well. You don't have to follow along. For example, horizontal. So this one will be basically give you like if you press D on your keyboard, this whole function will return 1. If you press A, this one will return -1. I'm just going to quickly get into the editor real quick. So like, for example, if you go to edit project settings, and if you click the input manager, you don't have to follow along, but if you like toggle the axis part, you can see that all of the like most of the keys were basically bound to a key. For example, on horizontal, you can see that positive button is right. So, or like alternative of it is D. So whenever you press the key button D, this function will return -1. Sorry, like if you press D, this one will return 1. And the negative will be returned, -1 will be returned if you press A. These ones will make more sense when we get into player movement. What I wanted to do is I really wanted to show you that they are basically kept in this field. And like, for example, I just explained how horizontal works. But this part in here, for example, mouse X, as you all remember, maybe I can just, or nah, forget it. So yeah, as you can see, we just use mouse X, and mouse X is also configured right over here. So if it's not making any sense, just don't worry. Just know that this functionality will return a plus value if you're moving your mouse horizontally, and this one will return 1, a positive value if you're moving it vertically, and vice versa. So yeah, and I can just delete this. Then we can just make changes to the camera rotation. As you'll remember, for example, if you want to make changes to the position of our character, we can just do transform that position. But this one only applies for position. Instead, we're going to use local rotation. Whenever we move our mouse, we're going to basically make changes to the local rotation, just like this. Now, that is, this part will be a little, complicated. So we're just going to create a quaternion and called Euler, a static function that will take in an x value, y value, and a z value. These ones will, like this x, y, and z values will correspond to the rotation. It's going to compile, yeah. Like the values, the x, y, z will correspond to these x, y, z. And whenever we move our mouse, like for example, you can just play around with it. Like whenever you make changes to these rotations, like obviously the player will rotate, and like z-axis as well. But yeah, basically what we're doing is we have like new values. We basically change this mouse movement and attach our values to create a new quaternion object, and that will be the rotation, the orientation of our game object. It sounds a little complicated, but when you think of it like this, so this whole function will just rotate my character based on mouse input. Like you don't really have to understand it fully, but that's basically what it's doing. In here, uh, it's going to be like you're seeing float x, float y, float z. So you would expect to do something like mouse movement x, mouse movement y, and mouse movement z, but that's not entirely the case. I'm going to show you why. So for example, if we do something like this, and if we get into, or maybe like I should just show it to you. This, by the way, like this part is not correct. I'm just going to show how it's going to react. Like, why is this open? Anyway. If we play our game, so currently I'm moving my mouse horizontally, and if I move my mouse vertically, it's going to move the other way around. The reason for that is, like when you change the x-axis, like when you rotate the x-axis, it's moving like vertically. You can think of it as like, or like maybe if you get into the rotate tool, just like this, like you can think of it as like moving the x-axis as a whole, just like this, and that's why the rotation is sort of like reacting like this. So in order to get the correct output, what we want to do here is change this x value to y, and also add a minus value to it. And yeah, that's basically it. So I'm just going to wait for a while for you to copy it. And it's pretty simple. It's actually like 3 lines of code. The only thing is that like this part sort of like includes some vector mathematics. You don't really have to know like everything about it. So yeah, if you guys are all ready, we can just run our game and rotate our character just like this. And yeah, currently I'm moving my character, I'm moving my mouse horizontally and like vertically. As you can see, it's working fine. Perfect. So like any questions so far, I'm just gonna open up the VS Code so that like, if you missed anything, any questions? And obviously we don't really care about the z-axis. We're just gonna keep it 0 because like if you change the z-axis, it's just gonna, you know, move the character sideways. We kind of don't want that. Yeah.
So can you explain the difference of 0 to Z?
0 for Z, yeah, like because we are sort of like whenever you move the z-axis, you're gonna see that the character reacts sort of like this, and we don't want that. And like for example, in some other games, like some FPS games, sometimes you just like peek a corner and your character does this.
Yeah.
Maybe like you can add that functionality and like change the orientation of the z-axis just like this to add some feature to it. But because of the like currently the only changes we can do here is like two-dimensional. We can just either go this or this. Yeah, like in order to add a third dimension there, like maybe like if we maybe like if there's a, I don't know, a mouse for it or like any other button, any other input that you add, maybe like you can make some changes with the Z orientation as well.
Yeah.
All right. You're welcome. So yeah, that was basically the rotation. If you're all, oh yeah, and also I'm just gonna quickly show you how to add a mouse sensitivity option. Um, it's pretty simple. You can just create public float mouse sensitivity. Like I don't know, maybe like change it to 5 or something. And what you have to do is you have to multiply like this. And if you get into the game, you're gonna see that it rotates a bit faster. Maybe like you can decrease the sensitivity a little, or you can just ignore it as well. It's really up to you. Like I'm just gonna keep it with a small value. Um, yeah, and also one other thing I want to mention is time, delta time. I don't really want to go into it in too much detail because I think I explained it in the previous workshop. But basically, as you all remember, like this one is also saying that update is called once per frame, and inside the update function, um, display rotation will be called, like for example, if your game is running in 60 frames per second, that means this function will be called 60 times per second. But for example, let's say you have a really fast computer and your computer is running in like 200 frames per second. So that means this function will be called 200 frames per second. But the thing is, since there's no consistency around here, we're just adding 200 times within a second. So that's sort of a lot. And we kind of want to make it consistent so that like even though your game is running in 60 frames per second or like 200 frames per second, we just want to make it similar to one another. So because of that, we are going to add a little variable called time.delta time. And by the way, this part is sort of optional. I don't think you will have like problems with this workshop, but in the future, that's definitely something you should be considering to keep your game consistent with different hardware specs. So time.delta time will basically give you the time interval, like basically it will give the seconds between current frame and the previous frame. So that like if your game is running too fast, um, this function, this variable will be small, and basically it will decrease this value. But since this one is being run, like this one is running 200, like 200 times within a second, it it will keep things consistent. Um, yeah, I think it's a pretty nice idea. Like as far as I know, like some of the old games doesn't really have this functionality. So like for example, if you're playing an old game with a computer that has high specs, you might see that your character is moving a little faster because they are not really doing this check over here. Um, yeah, and maybe you might want to increase the mouse sensitivity or not. I don't know. Yeah, yeah. If you're all okay with it, I think we can just. I'm just gonna test it. Sometimes it's just too slow when you apply time.delta time. Yeah. So since this one is pretty slow, you can just increment the mouse sensitivity, or like you can just delete this part as a whole. It's really up to you. I'm just gonna keep it. So any questions so far? Do you have any questions? Like were you all able to like rotate the camera and stuff? Like perfect. All right, let's get to the other part, the player movement. I'm just gonna like close this tab. Like if you just copied it, that's fine. So yeah, um, player movement. So this part is a little bit complicated, and it might, include some physics or like vector mathematics as well. Um, like I mentioned earlier, I won't be using physics. Instead, I will be just manually sort of like moving our character to keep things a bit more simpler. Let's just create a variable, a float variable that takes in input.get access horizontal. It's pretty similar to what I've done in here. Instead, we're using the horizontal part for this one. And float z, this part is important. Um, like we're using z-axis instead of y because like if you get into the scene view, you're gonna see that y-axis corresponds to like going up or down, and z-axis is going front or backwards, while x-axis is moving right or left. That's basically it. So we are not gonna implement any jumping or like flying mechanism. Um, so yeah, let's just do get access vertical, just like this. Now, um, I'm just gonna create a new vector tree with the name of local move dir direction equals to new vector tree x 0f z and normalized. I'm just I will explain why I used normalized here. Like many of you probably understood why I did that, but that's fine if you don't. Vector tree world move direction equals to transform. That is sort of the complicated part, but I will try to explain it. So yeah, what we have done so far is here. in here, what we have done so far, we're basically getting the user input. If the user presses D, this X value will be 1. If the player presses the A key, this value is going to be -1, and so on. And depending on the user input, we're basically going to change it into a vector, a unit vector. So local move direction will basically give you the direction vector that you want to move to. Like this one is basically, we're basically converting the user input into the vector space. For example, if you press W, this one will be 0, 0, 1. And I'm just going to show it to you. Like, for example, you can just use this variable as well. Nah. You don't really have to follow along in this one. I'm just going to quickly show it to you. For example, like if you call, these ones are basically some little static fields that Unity provides to you for simplicity. But you can see that vector 3 forward corresponds to 0, 0, 1. And like vector 3 left means -1, 0, 0. That's basically vector mathematics. And so yeah, the reason why we are normalizing it is that, let's say if you want to move diagonally, so maybe like it would make a lot more sense if I explain it afterwards, but if you press like W and D at the same time, the vector will be like, the vector will look something like this. And like if you remember from the vector mathematics, like this one's magnitude will be something like 1/1.4. So that's sort of like more larger than just a single unit vector. So we kind of want to normalize it so that like we won't be moving faster when we are moving diagonally. So yeah, and in here now, like we converted our user input into the vector representation. Since this one is just going to be something like 1, 0, 0, 0, 0, 1, we kind of want to convert it into our curve, like we kind of want to convert it into world direction sort of thing. So like, for example, I'm staying like this and this is my forward. And like if the character rotates like this, like the vector, the direction of the character sort of changes. And we basically want to incorporate this change to the real game so that like we can move our character consistently. So I will I will explain it a little bit further after I do the other parts. I think it will make more sense. Um, so yeah, and then I'm just gonna create a new vector tree called dpos, or like you can also call it velocity. I'm just gonna add a speed value, or like maybe call it over here, or like you can also use it right over here as well. Speed times world move direction. So basically, this one is going to be the direction that we want to go, and this one is the speed, and this one will basically give us the velocity. And later, vector 3 new pos is transform that position, our current position, and we're basically adding the velocity, the unit velocity to the new position, and change it to the transform position equals new pos. just like this. So like I'm gonna wait for a while for you to copy, and like maybe I can just make it a bit bigger. And I just placed this speed value in here. You can make it global, just like what you have done with the mouse movement variable, just like over here. But just for like simplicity, I'm just gonna keep it over here. Are you all done with like adding those values? Yeah, perfect. So let's get to the game. When we run our game, and if you press, oh no, I'm going too fast. Maybe I can just, oh, and also like just like we did right over here, we added time.delta time, right? When we are calculating the velocity, be sure to, oh yeah, so yeah, like when we are calculating dpulse, be sure to add the time, delta time as well to keep it consistent. Um, and yeah, I'm just gonna move the character. Why it's going too fast? Maybe the speed. Maybe I'm just gonna change the speed to 5. Yeah, it requires some little tuning. What value did I use? 5. Alright. Yeah, 5 is a normal value, it seems. And you can see that our character sort of flies. And we don't want that. After we do this, so yeah, and also I'm just gonna add a little like print statement right over here to visualize the local move and world move a bit better. You don't have to follow along in this one. This one is just for visualization, just to show the difference between local move direction and world move direction. Debug log. So by the way, this function will be called, like this debug statement will be called whenever one of these buttons will be pressed, right? So when we get to the game, if I, like for example, I'm just pressing W. You can see that when I press W, it's a bit like small. It's basically going to convert it into a world direction based on my current orientation, so that the velocity will be applied a bit better. And like for example, if I'm rotated to a bit upwards, you can see that the y-axis, like in the world direction, the y-axis will sort of changes as well. Um, we kind of don't want that, and we basically change it to 0 after we make the calculation so that our character basically doesn't fly.
It feels like it's lagging behind. You could change get access to get access raw. Because get access automatically like softens the input and tempers it, so like it fades away after you.
Oh, I see.
But get access raw would be immediately. So it's like if you felt like your player doesn't stop immediately, that's why.
Oh yeah, maybe that's why when I'm moving it around, the local direction is something like this. Yeah, that's totally great. I see. Oh, and also I forgot to add one small thing. Like when you're playing the game, your cursor is basically around. There's a like simple method to like delete your cursor when you're playing the game, sort of. Lock state, cursor.
Okay.
Yeah, in the start functions, you can also add this one to, hide your cursor when you're playing the game. Like this. Yeah, you can see that my cursor is now gone. But in order to get it back, you just have to press escape to, actually quit the game. Yeah. And now we're gonna do the shooting part. I kind of have to hurry up a little, but like, do you have any questions? Do you have any problems that you have encountered that I can help? Perfect. So yeah, we're gonna get to the shooting part. So just like we have done with the input get access, if input dot access is fire1, no space in between, and that is not equal to 0, that means our character is pressing the left mouse button and we are trying to shoot, basically. And I'm just gonna, create a new, no. I'm just gonna create a new function called shoot to make it more clean. You don't really have to do that. You can just add everything inside here as well. So yeah, we will be using raycasts in this one. So like just like from here, I will get to that. This one is basically a raycast. We're basically setting the origin of it, and like this ray will be created, and it will basically give you all of the objects that it collides with. So it's basically like this: physics dot raycast, and it will be transform dot position. Like it actually has a lot of different overloaded, different versions of this function. So we're just going to use one of them, transform direction to vector 3 dot forward. This part is a little complicated, so I'm just gonna like have some spacing so that you won't have any like errors with it. So yeah, and also let's just outside of it, let's just create a raycast hit like this. So then let's have a comma and print out hit. And I don't know, gun range. Let's just create a float variable called gun range. And I'm just gonna call it 500. Just like this. So what this is doing is we basically provide it with a starting position, which is our character's current position. And then we provide it with and we also provide it with a direction. And maybe like you may remember this functionality. This one is basically converting the local direction to the world direction. So obviously our character might be rotated to like we basically this one is basically the local orientation of our character. We are basically converting it into the world position, world rotation. Yeah. Oh yeah, sorry about that. It's better.
Yeah.
All right. So we basically provided with a position and a direction. It will basically go infinitely. No, sorry, not infinitely. You can also set it to infinite, but we have a gun range, right? It will just go 500 units. It will basically create a ray with the length of 500. And this out hit thing over here will, so like if this ray that we have just created collides with a game object, this raycast function will return true. Simple as that. And it will basically store the information of the collision inside this raycast hit variable. Just like this. And yeah, in order to visualize raycast a bit better, we can just create something like this. Like if you're done with copying this part, you can also like do this. Draw, debug, draw, ray. This one will be only shown in the scene view. At least that's the case for on my end. Transform direction. Actually, the thing is you don't really have to follow along on this debug draw ray. If you want, you can obviously. So yeah, as you all remember, these three functions will be called within like every frame since we are calling them from the update function. And like whenever the left mouse key is pressed, the shooting mechanism will come into play. But what I want to show you guys is to like what I want to do is we can actually show the or no, I haven't saved it. I'm sorry about that. When you save it with the debug.draw ray, as you can see, like there's this little ray going around like on our player, right? That's basically sort of like a visualization of the raycast that we're going to use. Like I said, you don't really have to have this. And like this raycast function will return true if it collides with something. Now, if it returns to true, we can just debug.log about the information about what we have like collided with. You can just hit .collider and get the name of it. You can also obviously customize this debug message. You hit something just like this. If you get to the player, like you hit surface, why? Oh yeah, because I clicked. So whenever you click, you can see that if it, or like you can also create some game objects to have as a reference. But yeah, like if you shoot the ground, you will see a debug message saying you that, oh, you just collided, you just hit the surface. yeah, you hit cube 3 and so on. So now we can get to, like, by the way, like any questions, we will get to the particle systems, the explosion effects. Whenever we shoot our gun, we will basically create an explosion with particle effects. Maybe I can just zoom it a bit more. That's basically a basic functionality. Are you all ready? Like, are Christian? Yeah, all right. I'm a little hurrying up, but we can make it. So yeah, I just want you to create a new. Oh yeah, in the effects tab, just right click to the scene view, right? Right click to the scene view, get to the effects, and you're gonna find particle system right over here. Right click to here, effects, particle system. Simple as that. And yeah, when we created this particle system, you're gonna see that like it has this default sort of like effect that Unity provides you with. And like if you check the inspector tab, like you will see tons of different things. Like to be honest with you, I only know like 20 or like 30% of them. So like you don't really have to. And also like there are some other things that you can customize as well. But yeah, for this workshop, we're just gonna create a very simple explosion effect. So what I want you to do is now let's just create a folder called prefabs. And like after you don't really have to create this one, but it's a good practice. After that, just drag this particle system to the prefabs. We're just going to use it, we're just going to customize it as a prefab. And instead of having the name particle system, you can just name it as explosion, just like that. And yeah, we have our prefab now. We don't really need this anymore. I'm just going to delete it. You can keep it if you want. Yeah. So we have a bunch of stuff over here, and I'm just going to look some of them up. So yeah, first of all, I would like you to change the duration right over here. It's placed right over here. Instead of like 5 seconds, let's just change it to 0.3. And obviously like in the explosion tab. And also you can just take away the looping option. So like if you want this little effect to be a one-time thing, you can basically uncheck the looping tab. But just for visualization, I'm just going to keep it here. And also like if you don't see any effects, just be sure to, click play right over here. Sometimes it's missing, just like this. Yeah. And then what I want you to do is I'm just going to change the start lifetime, this thing. Instead of 5, I want you to change it to 0.5. And also you can just play around with it. And I kind of see that the particle effects is not looking good at the moment, but like it will get better. And start speed to 12, the thing right under it. Start speed to 12. Then we can check the 3D start size and change it to something like 4 or like 5. Like it's really up to you. Like the starting size. Then you can also change the color of the particle system, just like this. But to make things a bit interesting, just click to the like little arrow right next to the color and pick random between two colors. Have you all done it? Random between two colors. This little arrow right next to the color. Yeah, and you can basically change it to whichever color you prefer. I'm just gonna make it something like yellow to orange. Just, yeah, play around with it. Then, after you're all done, be sure to uncheck this play on awake thing. Like if you want to, run this explosion effect when this game object sort of like enabled or like awakened. But I kind of don't like that. It's not going to make much more difference, but you can just uncheck it. Then stop action. So this part is sort of important. Actually, not really, but like in the stop action, right over here, like bottom third option. This one is basically like after this animation ends, what should we do with the game object? I'm just gonna select destroy because like we're just gonna create a lot of game objects with this particle system effect, and we like after they're done with the animation, we just want to destroy the game object, just like that. Then click the emissions tab right over here. When you click the emission, it will open up a new tab, emission, right over here. Then you see this plus button. Just click it and it will add a little burst to our particle effect. You can also increase the count in here if you want, or like cycles, interval. Like there are a lot of different things that you can play around with or whatever. Yeah, just like this. Just add a little burst there and the shape. Yeah.
Where do you actually have that texture? Where is purple?
Purple? Oh. Try create, so it's regarding with the materials. Try creating a particle system on this scene tab. Yeah. Or like, no. If you create it like this, it will automatically have some of the. Yeah. Oh, and also like, is yours working fine? Like, you get this view of everything? Perfect. Now we can get to the shape part. We're just gonna change the shape of the explosion. Currently, it's like in a conic shape. We just want it to be a sphere so that like it's a ball sort of. Let's change it to sphere. Right now, it's more like a explosion. And if you want, you can also change the radius. Like in my notes, I changed it to 0.38. I don't know why, but it's your game. It's really up to you. Whichever one you prefer. And now, are you all done with it? So finally, you can get to the renderer part. In the renderer, there are a bunch of things that you can add. For example, like remember that I showed you how like materials work to change the color of the surface and stuff. You can also add those materials inside here. Like if you want, I'm not gonna do that. Like sort of like creates a weird explosion effect. Just stick with the default particle system. If it disappears, be sure to like play it right over here. And if you're all done with it, we're just gonna incorporate it into our game now. Okay.
Can you just go over the settings that you changed?
Settings.
Yeah, for the particle system. Like what you changed.
I can actually show you my. So now we have this prefab, right? Everything is ready. And then what we're going to do is we get to the scripting again. So let's create a global variable, public global variable that happens to be a game object, bless you. And game object explosion prefab. If you attended the previous workshop, you can kind of like see what I'm about to get, like what I'm getting at. I'm just gonna instantiate new explosion game objects whenever I shoot somewhere in the game. So like if you have this one, perfect, save it and be sure to attach it. Oh yeah, sure.
When you say explosion prefab, is that just a naming convention or is that the name of your part file?
No, you can like the variable, you can actually name it whatever you want. Like if it's a game object, that's sufficient basically. So now be sure to like, you're gonna see that explosion prefab thing is going to be empty. Just open up the prefab folder and drag the explosion prefab right over here. From the prefab that we have just created, just drag it to the player script. So are you all okay with it? Just attach it. Yeah, perfect. So let's get to the shoot function that we have just created. Remember, if this one returns true, that means it's collided with something. And we're just gonna create a little game object called temp explosion, temper like or child. I don't know. Like you can name it whatever you want. This one will be the instance, the copy that we're just gonna create from the blueprint prefab that we have just created, right? Instantiate and use the explosion prefab. If you'll remember, instantiate is going to take in a game object and basically create a copy of it. So we have this reference explosion prefab that we've just created. We're just copying it and we're just gonna change its position to where we are shooting basically to create this explosion effect to that position. So if we collided with a game object, that means that this temporary explosion position should be located right over to the collision point. So we're just gonna do hit point just like this. Is it clear? So as you like, I want you to remember raycast hit is holding the information of the collision between this raycast and the game object. You can actually access the like with this hit variable, you can access information of the game object, the collider of it, like anything, the name, the current position, and so on. Yeah. Then let's just create the explosion particle system. So since temp explosion is just a game object, we're basically getting the component particle system component and calling the play function into it so that this explosion effect will come into play. We're basically calling the animation with this play function. Is that clear? Have you all done it? I can just wait. Yeah, are you done with it? Yeah, perfect. Now we can just try running it in our game. If you have the explosion prefab attached, yeah, we can move our character and nothing's happening, probably because I haven't saved it. Unknown behavior, what's going wrong? Whoop, just like this. And I kind of forgot something. If you go to the explosion tab and like uncheck the looping, like it's, yeah, just get into the prefab and like uncheck the looping so that like the explosion effect goes away. And but the thing is, we can only shoot other objects, so there might be some other cases where we don't, our raycast won't be colliding with any other game objects, right? So I'm just gonna apply the functionality to add this explosion effect to the sky if we miss a game object. So if we cannot, if the raycast cannot collide with anything, the temp explosions new position should be located to transform direction vector 3 dot forward and gun range, just like this. So like this transform direction, we used it a lot of times. It's basically like I explained it a bit. Like I explained it before, but it's basically we're trying to shoot the front, but if our character's orientation is sort of different, it's basically converting it into the world view. And if you play the game, and yeah, I have it saved, you can see that even though if I like miss the, like even though if I miss any like game object, we can still shoot the sky because like we added a range to it, sort of. And obviously you can play around with it if you want. You can make changes to the explosion effect to, I don't know, like maybe you can uncheck, sorry, the check the looping part so that like the explosion persists. You can make the changes, the sizes, like everything, just like this. But I suggest you to sort of like close the looping thing because like there will be a lot of game objects created and like the frame rate might, you know, go down. And yeah, like were you all able to done it? Do you have any questions? Do you have any problems that you have encountered? This one is basically a very simple explosion effect that you can create without like any dependencies. You don't really have like Unity has like support for shaders and like you can obviously make tons of different things with it. And like for example, I have slides over here. Like for example, all of them, like all of the things you see here are like actually done with Unity particle systems. So like if you want, you can create your own way of things with those, or like you can actually import some you know, particle effects packages on the Unity, what's it called, Unity Marketplace, I don't know, but like yeah, you can basically take them and add it to your game. pretty much. And so, like, you guys all able to do it, right? I don't really have to. Yeah, perfect. And thank you all for attending. These are basically the references I used, and these are useful links. And yeah, we will have a game jam, and you're all welcome to join. Maybe like Liz, do you want to talk about it?
Just in case you're not aware.
Yeah,
So register.
yeah, we will have food. We will have.
That's it.
That's it.
I don't know. We're trying to say we can do private, but we'll see.
Yeah, like
But
Just
a
to
lot
talk
of this
about.
was on the registration report at the top, but not like the registration form. And if you have any questions, you can just ask me. Also, register doesn't mean you are forced to attend. So we're not gonna do that. Just like that's what that QR code is.
Yeah, and also like if you have any feedbacks to me, you can just scan the code and like tell me if I did good or bad. You can join our listserv. You can join our Discord, and our next workshop is going to be next week, same time, same place. And I guess tomorrow we will have a RenPy workshop, which is, I don't know, related to visual novels. If you're interested in that, you can definitely join. And yeah, thank you all for listening to me.
Tomorrow where?
Thank you.
I can't go tomorrow in class.